Hey guys, let's talk about factoring today, all the different methods. So the first method is called the greatest common factor method, shortcut GCF. You want to try this on every single problem. So if you're wondering, hey, should I try the GCF method? The answer is yes, you should, every single problem. So here's an example, 5x squared plus 25x. So what I'm going to do is I'm going to factor out the greatest common factor, the greatest factor that these terms have in common. So notice they have a 5 and an x in common. Oops, I'm trying to write with one hand here. There we go. So I could notice between 5x squared and 25x, between 5 and 25, they both have a 5 that we could take out. And between x squared and x, they both have at least an x. So my GCF is 5x. So then I'm just going to fill the rest of this in by using the distributive property. So notice as I double check, 5x times x is 5x squared, and 5x times 5 is 25x. So once I get the GCF, I fill this in by kind of saying what times this would be that, and what could I put here times this would be that. There you go. So that's called factoring out the greatest common factor. So the next method is called the difference of squares, and here's a problem that involves the difference of squares. Now, it's called the difference of squares because it has to be a difference. In other words, it has to be a subtraction problem. So you can't use the difference of squares method on an addition problem. So if this were a plus sign, you just wouldn't even do this method. You'd go on down the list. So anyway, keeping with what I said earlier, you always try to factor out the greatest common factor. The first thing I'm going to do is factor out a 4 here. So notice I'm going to factor out a 4, and this becomes that. So you always factor out the GCF, and in this case it's 4. But notice that what's left over here is a difference of squares. You can tell something, you can tell an expression is a difference of squares if it is a subtraction problem, if it has two terms, and if both terms are perfect squares. And these are perfect squares because 2 times 2 is 4 and x times x is x squared. Obviously, it's a subtraction problem, and it does have 2 terms, x squared and 4. So here's what you're going to do. So you're going to write down the 4 that you previously factored out. And then in the other parentheses here, you're going to put an x here and an x there because x times x is what it is that gives you x squared. X times x is what it is that makes x squared a perfect square. And then we're going to put 2 and 2. So 2 and 2, because 2 times 2 is 4. 2 is the term that makes 4 a perfect square. And then you finish this up by making one addition and the other one subtraction. So 4x squared minus 16 becomes that. 4 times x plus 2 times x minus 2. It's called the difference of squares. The next method is one that you do with trinomials, and one that you do with trinomials in particular where the a term is a 1. So a trinomial means you have 3 terms, and the first term is a 1. So here's a trinomial, 1, 2, 3 terms, and this is 1x squared. So the a term here is a 1. So when that's the case, it's very easy to factor just by using something called the guess and check method. So we're going to put down 2 sets of parentheses here. The first blank's pretty easy. X times x is what it is that multiplies to be x squared. The next one's a little tougher. You have to think, hey, what multiplies to be negative 12 but would add to be negative 1? So notice that negative 4 and positive 3 would do that. So negative 4 times positive 3 is negative 12, and negative 4 plus 3 is negative 1. So that's the trinomial method. Guess and check using trinomials. The next thing is a trinomial where the a is not a 1. So notice this is a little tougher. A is 2. So that's a little bit tougher. So there's lots of different methods for this. I like to use this little AC method. 2 times 5 is 10. And so write down the 10 and then be thinking, hey, what would multiply to be positive 10 but would add to be negative 11? If you think about that for a second, you're going to realize that that's going to be negative 1 and negative 10. So negative 1 times negative 10 is positive 10, and it does add to be negative 11. So what you do is you write that down over here with an X. And the reason you write an X is because we're trying to say, hey, these two things added together would be this. And then underneath it, you put a 2x squared, which is this first term here in the problem up here, 2x squared. And then what you're going to do is reduce and cancel out some x's. So notice I could cancel this x with one of those, this x with one of those. 2 goes into 2, 1 times 2 goes into negative 10, negative 5 times. So here's my final answer, 2x minus 1, and then x minus 5. So there's my answer. Now, where did I get that? It's because I have 2x minus 1. So bottom up, 2x minus 1. So 2x minus 1 and 2x minus 1 there. And then x minus 5, x minus 5. Because I canceled out those x's, I only had an x left on the bottom. So that's a little trick that works that makes that pretty easy to do. The next method's called grouping. It's what you do when you have 4 terms. Notice 1, 2, 3, 4. And all you do there is just group the terms together. So I'm going to group these two together. I'm going to put an artificial addition sign in between there. So I put a little plus sign here because I wanted to keep this negative there with that. And then you just factor out the greatest common factor on each one. So notice the greatest common factor over here is a 2x. And then that way this would be x minus 5. So I factored out a 2x just using the GCF method with these two terms, kind of like what I did on the first method. And then, of course, this times this is that, and this times this is that. Now put a little plus sign in there to keep these separated. And notice these don't really have a GCF. So really all I could do is maybe factor out a 1. You know, there's nothing they have in common. So you could always factor out at least a 1, even if you think you can't factor out anything else. So notice that what's left over is the same in both. Uh-oh, wait a minute. It's not the same. So if they're not the same, what you have to do is change the sign on this. So notice what I'm going to do here. I'm going to put this in a little negative here, negative 1, which makes this positive x and makes this negative 5. Now they're the same. We need these to be the same. If they're not the same, it means one of two things. It either means you need to do what I did, change the sign of this number out front, or it means you made a big boo-boo and you just need to start over. Something's not right. So I was able to fix that. Just change the sign here and that made it perfect. So notice that you write down x minus 5, which was the common term here and there. That was the same, so I can mark that out. And then right up against it, signifying multiplication, you write down 2x minus 1. This is where I got the 2x from. Here's where I got the minus 1. So that's called the grouping method. Last method we're going to talk about is the sum or difference of cubes. This works for addition or subtraction problems, and these have two terms. The difference is this is a perfect cube and this is a perfect cube. The difference in this method and the difference of squares method. So this is a sum or difference of cubes because these are cubes, not squares. Anyway, so you throw down a small set of parentheses and a large set of parentheses. We're going to put 2 blanks here. We're going to put 3 blanks there. In this first blank, you put down what is it times itself 3 times that equals this. Well, notice 2 times 2 times 2 is 8, and x times x times x is x cubed. So 2x is what makes 8x cubed a perfect cube. Also, similarly, notice that it's 3 that makes 27 a perfect cube. 3 times 3 times 3 is 27. So the operation that's going to go here is the same one that's here. So if this had been addition, you would put addition there. Since this is subtraction, you put subtraction there. And then all of these are going to come from over here. So this blank is that one times itself. 2x times 2x is 4x squared. This middle blank is that times that. and it's going to have the opposite sign here as what you had over there. So 2x times 3 is 6x, and this is going to be addition because this was subtraction. And then the last blank is going to be that term squared. So 3 times 3 is 9, and the last operation here is always addition. So those are 6 different methods for factoring. If you can master these, it's going to help you on all the different types of problems. I know I've gone fast. You may need some other examples. You can probably find some other examples on the internet, or you can find some other examples on this channel. But hopefully this helps a little bit. Bye.